Welcome, everybody. My name is Dan. I'm an observability architect at New Relic. I'm also a maintainer in the end-user special interest group in OpenTelemetry, and until recently part of the governance committee with Juraci as well as others. I talk about observability a lot, and you can see all of that in my personal site. And I've also written a book that goes through some of the topics I will be talking about today. And I've got with me Juraci.
Yeah, my name is Juraci. I'm a software engineer at OllyGarden. I'm a member of the governance committee for OpenTelemetry. I'm a CNCF ambassador, and previously I was a maintainer of a few modules of OpenTelemetry Collector. I was a maintainer of Jaeger. And on my free time, I like to create content around OpenTelemetry. So if you are interested in OpenTelemetry, follow Telemetry Drops on LinkedIn or YouTube.
Okay, so there is a lot of bad telemetry out there. But today, we've only got time for two common cases that Juraci and myself have seen around the telemetry space. But first, we're going to start to discuss what we mean by telemetry and what we mean by bad telemetry. So, to define telemetry, I think we need to go back to the definition of observability. Observability as the quality of a system that allows us to infer the internal state of that system from observations of its external outputs. Telemetry is those external outputs. So it's the data that our systems emit to be able to understand them, right? So what is a system? Like, you might think a system it could be a service. It could be a single service. It could be a single process. But the reality is that it rarely is. It's normally, in modern distributed systems, your system is a collection of dependencies. And this collection of dependencies needs to be understood because your clients are normally going to be at the other side of that distributed system. So when we're thinking about inferring the state of a system, that's what we talk about. And what type of telemetry do we need to be able to do this? Well, I think everyone here probably understands the concept of a trace. We need a trace to propagate context through that distributed system. We need semantic conventions that allows us to correlate our metrics to these traces via standard attributes. We need exemplars that allows us to give specific samples that we're going, or specific traces that we're going through that system when a metric was recorded. And we also need to correlate that to logs that may or may have not been instrumented with OpenTelemetry, where we can inject context. And that context is what allows us to understand what's happening in the system, right? We also need continuous profiling. Again, injected or correlated to the rest of the telemetry. Most importantly, we need to understand what the user is doing. So we need that telemetry from the browser, from the mobile devices and so on to be correlated to backend events. But let me tell you what, this user here, they don't care about your CPU utilization or your memory, so we need telemetry that is domain-specific, that allows us to describe business outcomes, that allows us to describe what the users of your application are doing, right? And that is something that can only be done with manual instrumentation. And that's probably when we start to see some cases of bad telemetry.
Yeah, and what is then bad telemetry? So we've seen what is telemetry. We've seen that the purpose of telemetry is to understand the state of a system at runtime. And what is then bad telemetry? And before making a definition of bad telemetry, I'm going to show you one example. And I'm sure you can relate to that. So you've seen logs like that before. Right? So you've seen logs, like info logs, that don't really tell you anything, like it works, still working, or an error that just says failed, or no details about that. That's not useful at all. Or perhaps something that contains PII in it, like emails or usernames or passwords, or just a stack trace, or just things being printed out to the standard out. And even by doing all of that, you've added logs everywhere, but you don't really understand what's going on. Right? So you've done all of that and still, I have no idea how it all works. So to me, the definition of bad telemetry is quite the opposite of what is telemetry. So telemetry is you understand what is going on with your applications at runtime, in production, potentially. And bad telemetry is telemetry that doesn't really help in that goal of understanding the state of application. It doesn't help you understanding that at all. Perhaps worse is if it delays the resolution of problems. So it's 2 a.m. in the morning and you have an avalanche of logs in there. And you have to sift through all of those logs to understand what is going on. Like, that's delaying your resolution. Even worse, if it breaks your bank. If it's a lot of telemetry that you're paying for, like high-cardinality metrics, for instance, like you're paying a lot of money for that, and it doesn't give you back anything at all. Or even worse, if it contains data that may cause you penalties, like if it has PII and you need to be compliant with some regulations, then that can break your bank. So that's bad telemetry. In summary, things that don't help you understanding the state of your application, or the things that are just noise, or things that breaks your bank.
Okay, so case number one. I think, as I said, we've got 2 cases. I wish we had time for more. Case number 1, which is when we get fast responses, but we get long traces. Who's seen a trace that looks a little bit like this, where the trace duration is about 12 seconds, but the response was served in 150 milliseconds? Then we've got like 10 seconds where nothing really happened, and then something else happened, right? And this trace, so the whole trace is 12 seconds, but the response is served in 150 milliseconds. So why is this bad? Why is this bad telemetry? The first thing is that it's a misleading duration, right? The trace itself is 12 seconds, but what we care about, which is the response to our clients, is 150 milliseconds. So if you're sifting through like all those traces and you start to maybe focus on the traces that are long because you think something's happening there, maybe that's not where the problem is, right? It's difficult to visualize. What you saw there was a really easy example, like a really clear example. But imagine that over minutes, hours, I don't know, sometimes maybe days, when you've got a really long trace with many things that happen in the middle, and then long like gaps of nothing happening, right? It's very difficult to visualize, very difficult to reason about. Also, these spans, that was an async operation, for example, right? Where something happened, trigger an async task, but they're causally related, but they're not really, there's no side effects. So like the response is already sent to the client, to your users, basically. And there was no side effects. Like we don't care what happens in that other, well, we do care as maintainers of the system, but the user doesn't care what happens at the other side of an async task, right? And perhaps the worst part of this is that if you're using tail sampling, you start to get into certain like things that are not optimized, right? For example, orphan spans or traces that are stored in half. Like you store the first half of the trace, but not the other half of the trace. Why does this happen? It's because in tail-based sampling, you have a window of duration that you wait for decision time. And then if that gap in the middle is longer than what you're waiting for the trace to finish, the tail sampler will say, I assume this trace is finished, so I'm going to make a decision. And then maybe the decision is different when the async task comes in. So yeah, you end up with potentially broken traces. But worst of all, you may be, because you're looking at the whole trace, the duration of the whole trace. If you're using that type of tail sampling, when you look at the whole duration of a trace, you may be storing, even if you store the whole trace, you may be storing a lot of traces that are long, but then the actual result to the client is actually okay. It's like, they're normal traces. And yeah, someone's going to come maybe and ask, why are we storing so many long traces? This is costing us quite a lot of money. Right, so this is the cost aspect that Juraci was also talking about. So when does this happen? And these are some of my past nightmares. I mean, common cases where I've seen this happening. The first one is like if you've built your own messaging instrumentation or instrumentation for messaging systems, you might not be following semantic conventions. And if you go to that link, you will see that semantic conventions for messaging systems have the relationship, this parent-child relationship between a consumer and a producer as an optional relationship. Normally, like you'll be linked with span links, which is something that we'll cover in a second. There are certain things where you may have been using an async framework in the past, and then you add OpenTelemetry instrumentation, and context propagation is magic. So then you start to see things like, for example, if you've got in JavaScript promises that are being reused, as in maybe you've got like a lazy loaded recursive poller that is basically returning the same promise, the same instance of a promise to the first method. The first method that calls that first caller that gets the promise gets associated with that context, and you end up with an infinite trace that happens to be the first, first request that go into that promise, you end up basically with an infinite trace with spans associated with it. It could also be that you're using thread pools, and for example in Java, we'll see an example of that. And then you sort of like you have an async task that you send into an executor, but you're not awaiting the result. Or basically, you've got a thread pool that is there's a scheduled thread pool. So like you just immediately say, I want this to be executed later, and I'm never going to wait for that, or like it might happen 10 seconds later. And also, if you're tinkering with backend storage for context, well, things could happen. So I would recommend that you use the OpenTelemetry signal APIs, like the metrics, traces, logs, and also the context API, and try not to touch what's underneath unless you really, really, really have to, because then surprises may happen. So let's have a look at an example in Java. What we've got here is a simple case. It's the case that you saw in the trace previously. We've got a method that is a parent method that is basically using an annotation to create a span that will wrap that method execution. And context propagation in Java is awesome. So it automatically propagates that context to threads if you're instrumenting that executor or instrumented that using the executor's instrumentation library. It will automatically propagate context. And when you basically create that runnable, it will wrap that into like the necessary functions to propagate that context to the thread that is executing that async task. So that's great. It's also great. And then we create a new async. We can create a new span in that task, and then this span will inherit the context that was propagated, right? And this is awesome. Like, to be honest, this is awesome. Like, this solves so many problems. But in this case, we're executing that 10 seconds later. And that's what you saw previously. We have that span, it creates that. It sends a task to be executed 10 seconds later, and this is what happens. So how do we fix this? 2 lines of code that will fix this. First one is we add a link. We add a link between span link between the span that we're about to create and the current context, basically. So the span in the current context. And then we say, I do not want this span to be a child of the current one, and basically say no parent in this one. That creates a new trace. So what happens with that? We create a new trace, and this trace now is whatever, 100 milliseconds. It has a link, and that link allows us to go to the other trace. So now we've got 2 traces that represent units of work. They're completely different units of work. They're linked between them by a span link, and then we can sample them separately, right? They all represent different units of work.
Yeah, and the second case that we have for today, and again, we only have time for 2, but one of the examples that I keep coming to is the health check traces. I suppose most of you here run workloads on Kubernetes, so raise your hands if you run on Kubernetes. Okay, yeah. And do you all have health checks on your containers, on your pods? Yeah, of course you do. What happens is whenever Kubernetes or the scheduler makes a call to the health check endpoint, if you have auto-instrumentation happening in your application, that generates a new trace for every single call that the scheduler makes. And those traces, they are typically of low business value. They don't bring you a lot of value. They are just like seeing if your application is up, and if it's not up, the scheduler is going to kill the pod and start again. So it provides very low value, and most of the time, it returns just a 200. Right? So it's really like, I don't need those traces. And the problem is they come with different names, shapes, and forms. For instance, in this case here, we have one such trace with 2 spans. So typically, health check traces are only 1 span. But in this case here, we have 2, because we have the Java auto-instrumentation for a Spring Boot application. So we have an operation handler span and the servlet level span. And that's useless. Like, I don't need that. Perhaps what I can make use of is 1% of my 200s would be fine for me to get a positive confirmation that something is happening, that this is working. But if I get a 500, then that's interesting. Or if I get a health check that is taking 30 seconds, that's interesting. But in that case, 1.5 milliseconds, that's not useful at all. In fact, I took a snapshot of the data that we received from users of OllyGarden, and among the top 50 endpoints, or among the top 50 root span names, which in Jaeger terms means the transaction name or the trace name, 17 of those were health checks. Like 17 out of the 50, top 50, were health checks. That's a lot. And they come with different shapes, because all of those redacted names that you see on the screen there, they're different contexts, like different applications that are running on Tomcat or Spring Boot. Right, so that's very hard to filter those. And they're very ubiquitous, like they exist for most of the users that we've seen data from. There is a very nice blog post on OpenTelemetry.io/blog on why it took 5 years to ignore health check endpoints in tracing. I see a lot of OpenTelemetry folks nodding their heads, like Antoine here, and I mean, it's hard. So take a look. This blog post is very nice, but the gist of it is you can configure the SDK to ignore the health checks. Right? So you can just blankly ignore. Like if you are like me and you think there's no value at all, you just filter them out at the source. That's the cheapest that you can do. It saves you processing, memory, network, storage, everything. Now, if you cannot do that for some reason, you can apply some tail sampling at the collector or just some filtering on the collector. But if you have like 2 spans, then you probably want to do tail sampling. The configuration for the collector is a little bit too big for this slide here, so you can see an example on my cookbook, on my repository with cookbooks. And this one here is for filtering health checks, keeping 1% of the 200s and keeping all of the non-200s. Right? So you can use that recipe for that case.
Okay, so in summary, let's take a look at some of the key takeaways from that we want you to take home from this talk. The first one is that bad telemetry has many side effects. Yeah, cost is one of them, but also the lack of, most importantly, the lack of reduced observability, like the lack of understanding in your distributed systems. Also, it can create noise. It can leak personal information or sensitive information. So all those are basically side effects of bad telemetry. It can come in many shapes and sizes. So, you know, we talked about leaky context and verbosity, but also maybe, you know, you're not observing semantic conventions and that creates back correlation. It could be in many, many different ways. But the good news is that OpenTelemetry gives you many different ways to fix it. It's up to you where you can or where you should apply the fix. For example, it could be in the API level, it could be at the SDK level, it could be at the collector. The important thing is that you have different ways to approach it. And it's up to you to decide where to best approach it. Now, one of the questions that we didn't cover is what happens in terms of governance and compliance, my 2 favorite words. Not really, but so we've got 2 very important projects that I would recommend having a look at. One is OpenTelemetry Weaver. There was a fantastic talk this morning by Ludmila about how Weaver can help you to do live checks on your telemetry data, and then basically start to see if it is observing your semantic conventions, and that's important. Your as well. It doesn't have to be the OpenTelemetry semantic conventions. You can manage your own semantic conventions registry. You can validate it. You can reference other registries as well, and validate that the telemetry that you emit is according to that. And as well, we've got instrumentation score.
Yeah, and while Weaver gives you the tools to validate and to verify and to understand your bad telemetry, instrumentation score provides you with opinions. So you can look at our somewhat strong opinions within the instrumentation score project. And in that project, we document what are the things that we understand as bad telemetry and what you should be looking for. What should you be on the lookout when you are operating a telemetry pipeline? So you should see, do I have to pay attention to high-cardinality metrics or to stale debug logs in production, and so on and so forth. So the instrumentation score is a knowledge base of what we as an industry, or we as people in the industry understand as bad or good telemetry. There is a talk tomorrow on instrumentation score at I don't know what time, but if you can scan this, the QR code, it goes directly to the entry on SCAD. Thank you very much. We'll be at the observatory starting tomorrow down there. I'll be more than happy to talk about the instrumentation score or bad telemetry in general. And if you got any feedback about the session, scan the QR code and tell us what you thought, what you think. I think we have a couple of minutes for questions, and I would be really interested in hearing what is your story of bad telemetry. Thank you. It should be.
The mic is on?
Is the mic on?
Is the mic on? Can you try again?
Can you try again?
Can you try again?
So,
It's okay. We can repeat the question, maybe.
the question has changed. Question is simple. You talk about PII. So, what areas you have seen PII? Obviously, logs, SQL queries, and so on. And if there's anything particular that we can.
Yes. So the question is, where are we seeing PII? I think the answer is yes. Everywhere, but more specifically, URL.query, URL.path, on logs as well. So we see a lot of PII in logs. And command line arguments. So if you're using the Java auto-instrumentation, and it automatically captures the command line arguments. And some developers, they think it's a good idea to pass the JVM trust store password in the command line instead of as an environment variable or in a properties file. And we've seen the trust store password in the command line arguments. So that goes into the telemetry, which then goes through the backend. But everywhere, basically.
And I think sometimes I like that, you cannot even, it's not something that you add yourself or that you can even control at the SDK or API layer. There's a very popular HTTP library in JavaScript that and in Node, the behavior is that if you don't configure an appender, basically, or if there is like an uncaught exception, it will basically dump it into console. And if you've got a log forwarder, this particular HTTP library will dump the whole HTTP request, including headers, into console, right? So then what you end up with is PII because you've got that PII in your headers. So you need to be, careful of these things. And the collector, for example, is a great way to be able to parse that and filter that.
And that is when you don't expect. But there are things that developers think that it's a good idea to add. Like I've seen telephone numbers in labels for metrics. Like some people thought would be a good idea to add telephone numbers as a label to a metric. So, and that's high-cardinality and PII at the same time. How to handle that at a collector at scale?
So there is a redaction processor in the collector that's able to look at specific regular expressions that you want to match. Of course, sort of what shape to look for, right? But the collector does have some tools that allow you to handle that.
You should go to the microphone, but yeah, so I can repeat this point there, that individual services can have different rules and you can apply different rules there. So I think there are two phases to fixing the problem. One is you really want to go back to the source and remove it there, because that's the cheapest. And the second one, you stop the bleed, which is you fix it at the pipeline. And then you have to pay the cost. What are your choices? The choices are either I send my PII to my backend and I cannot, or I do that in the pipeline. You should do it in the pipeline.
So I think just to add to that, I think that's the collector is always going to be a reactive approach. Yeah. Where with governance and measuring, you can move into a proactive approach.
Yeah, I understand, that has to be applied at the source. But from the collector standpoint, because I really love this session because it's the exact same problem we're having in my org. People just log everything, probably a lot of waste, And we do want to filter that somewhere down the line in a pipeline, where we have a bunch of collectors running and trying to pass this data and trying to find the bad data. So the problem we're having is, I cannot have thousands of filters in my collector because eventually it will impact the collector performance as well, right? So yeah, unless we build some custom processor that can do a lookup in some external table and try to filter data in a very optimized way, that's a different thing. So.
Depending on the architecture that you have, like it's typical to have a layered kind of collectors. Like you have collectors that are closer to your workload, like daemon sets or sidecars, and then closer to the namespace or to the node, and then another one at the cluster level, and then another central one, and so on. Like apply the closest to the sources as you can, but there is no like there are reduction processor and the transform processor, but yeah. That's where you should be doing, and the closest that you have there. You have no other option than to add those config files. You can decompose the config file, but it does add over, like, if you have thousands of services and thousands of rules, of course, you're going to have an overhead.
Yep.
You had a question as well? Oh,
I think we're out of time.
yeah, you can ask the question
We get one
outside.
So my quick question is about span metrics and service graph. So if you do tail sampling, how can we have the span metrics and service graph when they need a full set of your trace into your database when we need to do that?
Yeah, so the question is, how do you calculate the span metrics if you filter things out, like if you don't have? So if you do need the span metrics for the whole amount of your data, then you have to apply the span metrics before filtering. There's no other option. Yeah. There is one new kind of spec for sampling that applies, like what was the sampling rate by the time that a decision was made, but I think that doesn't apply to the collector at that stage.
Sure. Thank you.
Right, thank you.
Thank you.